Question 7. When anhydrous, that just means dry, aluminium chloride is AlCl3 because aluminium's in group 3, so forms a 3 plus ion. Chloride comes from chlorine Cl in group 7, so our minus ion gains 1 electron Cl minus, so I've got Al3 plus Cl minus, so I'm going to need 3 Cl minuses to balance up with the Al3 plus. AlCl3 therefore reacts with water, solution Y is formed. That's going to be hexa-aqua aluminium 3. So AlCl3 plus 6 waters to give the 6 water ligands around the aluminium. 3 plus because aluminium's 3 plus. No charge on the waters, they're neutral, and we'll make 3 Cls. They're going to be minus ions, chloride ions from the aluminium chloride. 3 plus and 3 minuses make nothing, and nothing on the left, so that balances. Give an equation to show how the complex ion Z can act as a Bronsted-Lowry acid with water. So you've got the complex ion, the hexa-aqua aluminium 3 ion, you've got plus water, and a Bronsted-Lowry acid means it donates H plus. So the water is going to become H3O plus, and the aluminium loses one of the waters. One of the waters, so I get 5 waters now, one of the waters loses an H, so instead of H2O it's just OH. And that becomes 2 plus. The water has gained the H plus and become H3O plus, and this is 2 plus. 2 plus and 1 plus make 3 plus to balance up with the 3 plus. The other way of looking at it, I suppose, is that aluminium is Al3 plus. No charges on the water, they're neutral. OH minus a hydroxide, and OH is a minus, and so 3 plus and 1 minus make 2 plus. Excess sodium carbonate solution added to Y. So what happens is the AlH2O reacts with the sodium carbonate. We know this is acidic, it's a Bronsted-Lowry acid, it releases H pluses. And what does sodium carbonate do with acids? Well, it releases carbon dioxide, and it's going to make a white solid. What actually happens is 3 of the waters now turn into OHs, so you end up with AlH2O3OH. This has no charge, and because it's got no charge, it's a solid. So I get aluminium hydroxide as a white solid or a white precipitate. I get bubbles, that's my carbon dioxide because I've got sodium carbonate with acid. We know this is acid. And the equation, difficult equation this, you've got to remember that a carbonate ion from sodium carbonate is CO3 2 minus. This is AlH2O6 3 plus, we know that. So to make a white solid, then it's going to have no charge. Something with no charge is not going to be able to bond to the polar water molecules, and therefore it comes out as a white solid. It's got no charge. So 3 of the waters are turned into OHs, and I make some carbon dioxide, and I'm going to make some water as well. So I've got the H pluses coming off this with some O's to make some water. There's a good chance if you've got H's and O's, you're going to make water. The problem is it doesn't balance. So how do I balance it? Well, the first thing to note is I've got 3 plus and 2 minus. So if I have 2 of these, that will give 6 pluses, and 3 carbonates will give 6 minuses. That's a start. So 2 of these and 3 of these gives 6 plus, 6 minuses. I've got 2 Als now, so I'm going to need 2 AlH2O3 OH3. I've made 3 Cs, 3 Cs, and then if you have a look at the H's, you can balance up all the H's and you find you need 3 H2Os, or you can balance the O's either way. Aqueous potassium hydroxide is added until in excess to solution Y. 2 observations you will make. Well, first of all, you will get a white solid. That's the same as this. Aluminium hydroxide, AlH2O3OH3. That's my white solid. But then with sodium hydroxide or potassium hydroxide, it will redissolve. So it redissolves, the solid dissolves or forms a solution. So let's have a look at the 2 equations now. The OH minuses from the potassium hydroxide react with 3 of the waters come off, and the 3 hydroxides are replaced. So that's going to give this with no charge. Remember, 3 plus, nothing on the water. OH is 1 minus, so 3 1 minuses and 3 plus gives no charge. That's why it's a white solid, because it's got no charge and doesn't bond then. It's not got a charge to bond to the polar water molecules. And 3 OHs then replace 3 of the water ligands, so 3 waters come off. And that's my solid precipitate, my white solid. And then if I add more OHs, another OH replaces an H2O. So one of these H2Os now becomes another OH, so that becomes OH4 and only leaves 2 waters. Now it gets a minus charge. We know it's a minus charge because there's 1 minus on the left, 1 minus on the right, or another way of looking at it is this is 3 plus, no charges on the waters, 1 minus for each of the hydroxide ions, that's 4 minuses, 3 plus, 1 minus, and one of my waters has been replaced by an OH now. This will now redissolve because it's got a minus charge, so it'll form a bond with the polar water molecules.